Hi everybody, welcome to Unit 6, Lesson 2, Evaluate Algebraic Expressions. Okay, so first off, this is one of my favorite parts of math, is algebra. I love algebra because it always just feels like a puzzle that we're trying to figure out, and so I just think it's so fun. But anyway, that's me, and Miss Angel's a big math dork, so maybe that's why. But we use algebraic expressions all over the place, whether we know that we're doing it or not. Okay, so it does apply to daily real life more often than you'd think. Okay, so first off, a couple key terms. An algebraic expression, it's an expression that combines numbers and or variables using operations. So an example would be like 3 plus x. That's an example of an algebraic expression, okay? Or even like if we have x over 7, right? Anything like that, we can expand it. It could look like that. It's like an equation, but it doesn't have the equal sign. That's the biggest thing about it, okay? And then evaluate, that's just a really fancy way to say solve the problem, okay? So anyway, let's get into some examples. Number 1. The formula for finding the surface area of a cube is 6s squared, where s is the length of each side of the square. Evaluate for s equals 10 to find the number of square centimeters for the surface area of a cube with side length 10 centimeters. Holy moly, right? It sounds big and scary, but it's really not that bad. So first off, we're talking about a cube, all right? A few things to know about cubes. Right? 1, each face is a square, right? And there are 6 of them, right? So I could draw a cube. It would look something like this, right? You could think of a box where every side is a square. You could think of a die, right? Like dice from like a board game, okay? And so it's a 3-dimensional shape. And what we are doing is we're trying to find the surface area, okay, of a cube. And the formula that we need is 6 times s squared. Well, area for rectangles and squares, right, or parallelograms, the area formula for that is length times width, right? So it would be like this. That could be like the length times the width, right? That's how we would find the area for that one side, right? And with squares, the length and the width are the same. So that's why we're able to do like s times s, because this length would be s, this length would be s, right? That's the same thing as s times s, or s squared. But we have 6 of them, so that's where this comes into play, okay? And what they're telling us in this problem, it says evaluate, right? There's that fancy word for solve. For s equals 10, so that means this is 10, this is 10, right? Each side length is 10 centimeters, okay? So all we have to do for this is we just plug in 10 into our expression. Now when a number is smushed right up next to a variable, that means to multiply. Okay, so really what this is, it's 6 times, and then we have 10 squared. Well, we know what 10 squared is, right? That's s times s, or in this case 10 times 10. You might even have it memorized, right, as 100. 10 squared is 100. So we have 6 times 100, well, 6 times 100 is 600, and then it was centimeters squared because, again, we were talking about area, and area, the units are always squared. So that would be your final answer, okay? So it looked big and long and scary, not too bad, all right? All right, let's try another one. Okay. Number 2, Gabrielle wants to put a border around her garden. It costs $1.50 per yard for the material. use 1.50, right, $1.50 times 2L plus 2W, where L is the length and W is the width of her garden, to find the cost for a garden with a length of 4 yards and a width of 3 yards. So there's a few things. First off, from the information that's given, we can assume that this is a rectangular garden. So we've got a rectangular garden, and it said that the length is 4 yards and the width is 3 yards. Okay? The reason why it's 2L plus 2W, well, because there's 2 of each side, right? Right? There's 2 of the 4s, 2 of the 3s. Of in math means to multiply. And then we would add all of those together, okay? And then what that's going to give us is all of the yardage, and for each yard, it costs $1.50. So we can fill in our equation. So we have $1.50 times 2 times 4, that's our length, plus 2 times 3, that's our width, okay? Because of the order of operations, we do what's inside parentheses first. So I can rewrite this. I've got $1.50, and then 2 times 4 is 8. 2 times 3 is 6. Well, I've still got more to do with the order of operations, right? We had parentheses, exponents, but this one doesn't have any exponents. And then next comes multiplication and division, right? That's what I just did there. And now I'm going to add those together. So now I have $1.50 times 14. Okay, well, I can actually do this in my head. $1.50, it's like $1.50, right? I'm multiplying 1.5 times 14. Well, 1 times 14 is 14. Half of 14 is 7. So add those together, right? And so 1.5 times 14 is 21. So our final answer would be $21. That's how much it would cost, right? It said to find the cost. To find the cost, right? That's what we were looking for, is how much is it going to cost her. Okay? Okay, my last one, I didn't write the whole thing down. I guess I could pull it up real quick. Let me see. This is number 1 from your quick check. It was kind of long, and so I didn't want to write it. So, sorry, Miss Angel is a little lazy with that, but I'll read it out loud to you. Mr. Imani wants to purchase paper and notebooks for his classroom. At dollar discount, he can buy packs of paper, P, that one, for $1.25 each, and notebooks, N, that one, for $2.50 each. This is modeled by 1.25p plus 2.50n. Evaluate for p equals 10 and n equals 30 to find out how much it will cost Mr. Imani to purchase 10 packs of paper and 30 notebooks. Okay? So all we have to do, they told us all of the values. We just have to plug them in and solve. So I have $1.25 times 10. We love that. I love multiplying by 10 because we just have to move our decimal point. And then we have $2.50 times 30. Now notice I put parentheses in there because if I didn't, I would either need to put my multiplication symbol or the parentheses. Otherwise, it would have just looked like this, right? Right? It looks like a completely different number. So we can't do that. So I added in the parentheses to show that I'm multiplying. All right? Because again, when they're smushed together, it means to multiply. All right, multiplying by 10, all that means is that I have to move my decimal 1 spot over to the right, giving me $12.50. I'm going to write it like that because I'm still talking about money, right? So I need to go to my hundredths place. Then this one, like, it might be a little tougher, right? It's still a multiple of 10, so I know I can move my decimal over 1 spot to the right, but then I do need to do 2.5 times 30. Just for good practice, let's go ahead, let's just write it out. We've got 2.5 times 30. Okay, I'm leaving this off because I don't need it when I'm multiplying. We can add it back in if we need to. So notice I don't have my decimals lined up. I don't need to have them lined up. Okay, I'm going to ignore them until the very end. Well, 0 times anything is itself, so I'm going to put that 0 in. And then now I can start multiplying with my 3. I've got 3 times 5, that's 15. I'm going to drop my 5, carry my 1. 3 times 2 is 6, plus 1 is 7. And you might have been able to do that in your head. 2.5 times 3 is 7.5. Okay, so, and that's helpful too. I have one number behind the decimal in my problem, so I need one number behind the decimal in my answer. All right, making it $75. I'll put in that last 0 just so it's talking about money. All right, and then adding them together, well, again, if we want to line them up, I'll bring this one down here. When you add, you do need to have your decimals lined up, okay? Because then it can come straight down into your answer. 0 plus 0 is 0. 0 plus 5 is 5. 5 plus 2 is 7. 7 plus 1 is 8. Giving me a final answer of $87.50. Now we could check our work on a calculator, especially this one, right? This one's a little more complicated. So I have $2.50 times 30. Let's make sure. Oh, good. It is $75, right? And then we could say, okay, over here I had 1.25 times 10. Ooh, good. That is $12.50. Add those together, you do get $87.50, okay? So it is good to check your work on a calculator just to be safe, all right? As always, if you need extra support, just let me know.